Joyce, and I'm an academic at James Cook University. So that means I do both teaching and research in the area of remote sensing. So largely I use satellite images and even drones to map and monitor the environment in which we live. So I'm out here at the moment on the Great Barrier Reef, and we're just off Port Douglas, which is out to my left. And if you have a look at the map behind me, this shows the area that we've been looking at as part of the survey trip. So why are we here? Why are we interested in the Great Barrier Reef? So the Great Barrier Reef as a whole is about 3,000 different reefs along the Queensland coast, and it spans for more than 2,000 kilometres. So all up, it's about an area the size of Italy. So it's a really big area off the coast of Queensland, and it's really important for us economically, socially, and also as a huge source of biodiversity. So we're really interested in the area and understanding exactly what's there, because if we don't know what's there, we don't know if things are changing or not. And obviously there's always concern about climate change and what's happening to different parts of our environment. And so we're out here just really trying to understand exactly what we can see on the reef. And then if we're able to make tools to map and monitor the reef, then we can understand how this is changing over time and what sort of environmental drivers cause that. So you may have heard a bit about coral bleaching, which is where corals essentially are getting rid of the plant that's within them when they're exposed to really high sea surface temperatures. And this was a big issue in January of last year, and we know that it's caused a lot of health problems for the reef north of Port Douglas here. So we're in an area where we know there's been issues associated with high sea surface temperatures, and we're out here trying to understand a little bit more about what's going on. So at the moment, like I said, we're just off Port Douglas. So you can see here's part of the reef that we're interested in all the way up here, and you'll see there's a couple of different coloured dots that are on the reef. And so we've got these red dots which indicate reefs that are close inshore to the land. Then the orange dots are reefs that are mid-shelf reefs, and the green ones are all of our outer reefs. So we're interested to see if we can see any patterns with a north-south gradient at all, so a latitudinal gradient, or if there's any variation in reefs as we go further away from the coast. So we've now been out here, this is our 9th day on the reef, and so we've been visiting one reef every day and surveying each of those reefs. So we've got divers and snorkelers in the water, and what they do is that they go down and they're taking photos of the different types of coral and algae that they'll see on the reef as they swim along the transit line. And then my job is to use drones to capture imagery over each of those reefs that we go and visit. And then we use that as an intermediate step between our field survey underwater data and what we see with satellites. So satellites are really the only way that we can hope to map this entire area. And what we're seeing in the 9 reefs that we've just visited over the past week or so is just a tiny snapshot of those 3,000 reefs of the entire Great Barrier Reef. So we use these field sites that we visit to calibrate and then validate our satellite image processing methods. Alright, so for this particular research trip I've got a combination of different drones that I have available. Now the reason I've brought more than one drone is because it's always good to have redundancy, and you never know what's going to happen. So thankfully for this particular trip I haven't needed my redundancy, but it makes me feel good to have it there in the first place. So this particular drone has been the hero of this trip. So this is a Dji Phantom4 Probe, and it's got a small camera here that you can see that sits on a gimbal, which means that it doesn't matter which direction the drone is flying, the gimbal will hold the camera nice and steady. This is really important when we're wanting to map the reef, so that we always have the camera facing downwards and that it's not wiggling all over the place, so we get decent photos that we can join together and make a map of. So this is a fairly high resolution camera, and when I fly this up at the highest altitude that we're legally allowed to fly, which is at 120 meters or 400 feet, this will give me a resolution of about 2.5 centimeters on the water. Okay, so that's one of the ones that we're working with. It has a small SD card in it, and it takes all the photos to that SD card, and then at the end of the flight we download those photos and put them away to process. So the other drones that I have, this particular one is a different brand. This is the 3D Robotics Solo, and I've used this on a lot of different flights. It has a GoPro, or you can change out different cameras, but flies really similarly to the Phantom that I've been using mostly for this trip. Both of these drones fit into the sub 2 kilo category, which is a category designed by the Civil Aviation Safety Authority here in Australia to allow people to fly without a license. So it's possible to fly these drones without having a commercial license to do so. The only catch with that is that insurance companies actually like you to have a license. So I am licensed to fly these ones, even though in theory I don't need to. I also have a smaller drone here with me this week, and so this is one that I've been using just in a bit of testing to start with. So this drone is about a third to a half the price of the slightly larger ones. It only weighs about 500 grams, and it has got a phenomenal camera on the front of it. So that's just in the nose that you can see, as opposed to hanging down in the gimbal. So it's nice to have that integrated. But it's a lot smaller, and it's been too windy to fly this particular one. Now all of the drones are flown with remote control. So this particular one belongs to the white drone, the Phantom that I showed to start with. So I can fly it manually using the sticks, like you may have done with gaming as a kid or whatever. But also I have an interface through an iPad that shows me where I am on the map and whereabouts the drone is flying. This is really important for the type of work that we do, because what I do initially is to look at the area that we want to survey, line that up with where we've got field data from, and then I plan out an area that we want to cover. So once I add that into the app, I can actually say, all right, so this is the area that we want to cover. I want to be at this particular altitude. I want to make sure that I've got a certain level of overlap between my photos. So I go for 90% overlap between consecutive photos as we fly along a line, and then 80% overlap between each individual flight line. So the drone comes backwards and forwards, taking photos as it goes, and then that makes sure that I don't miss anything out of the area that I'm covering. I also need to make sure that I take into consideration where the sun is in the sky. So particularly over the marine environment, when we've got water in our image, we get a lot of sun glint. So that really bright light reflecting off the surface of the water is terrible for our maps. So what we want to do is make sure that we fly the drone with its back or its butt to the sun, and also angle the camera just slightly forward, so that means that the sun glint is just off the photo, and that way we get a nice clear photo of the scene. So we have to take into account the sun glint, we need to take into account the direction that we're going to fly the drone, how high we fly it, how much overlap and side lap we need. And then the additional factors that we've also got while we're out here on the reef is considering the tide. So ideally we want to fly our imagery with low tide, so we can see all the corals as best as possible. And that's not always ideal, because sometimes low tide might be early in the morning or late in the afternoon, but it's another factor that we need to consider. We add on top of that the wind. So we've been really lucky this week. We're quite comfortable flying the drones less than 15 knots. When it pushes up to 20 knots, that's really too much. And today, for example, we can't fly anymore. So we've been getting gusts of up to 30 knots, and so we're not able to continue our mission for today.